Hello everyone, myself Chirag Gowda studying in Sri Venkateshwara College of Engineering, and today we are going to talk about information retrieval. In that we are talking about a probabilistic model. Let's start. Introduction to Bayesian network. Bayesian network are graphical models that represent probabilistic relationship among variables. They use directed acyclic graphs DAG to direct dependencies. Each node in the graph represent a variable while edges imply conditional dependencies. Components of Bayesian network. The main components of a Bayesian network are nodes, edges, probability, distribution. Nodes represent random variables which can be discrete or continuous. Edges indicate the conditional dependencies while probability distributions quantify those relationships. How Bayesian network work? Bayesian network utilize Bayes' theorem to update the probability estimates of hypotheses as a new evidence is available. They allow for efficient inference even in complex network with many variables. This makes them useful for various applications including diagnosis and decision support. A P a power b equals p of b power a into p of a by p of b. This is the Bayesian network formula. Conditional independence. Conditional independence is a key concept in Bayesian network that simplifies computations. If two nodes are conditionally independent, given a third node, the knowledge of one does not affect the other. This property reduces the complexity of the joint probability distribution. Learning Bayesian network. Learning Bayesian network involves estimating the structure and parameters from data. There are two main approaches: structure learning and parameter learning. Structure learning identifies the network topology, while parameter learning focuses on estimating the probabilities associated with the edges. Inference in Bayesian network. Inference refers to the process of computing the probabilities of certain variables given evidence. Common methods for inference include exact inference, approximate inference, and sampling methods. Each method has its advantages depending on the complexity of the network and available data. What data what is Bayesian inference? Like, take an event. Now evidence information which affects data set, and you have probability and updated probability. This two combined is the Bayesian inference. Application of Bayesian network. Bayesian networks are widely used in medical diagnosis to model the relationship between diseases and symptoms. They are also applied in risk assignments, decision making, and machine learning. Their flexibility allows them to be tailored to variety of domains including finance and robotics. Comparison with other methods. Bayesian networks differ from traditional probabilistic models by incorporating direct relationship. Unlike Markov network, Bayesian network allow for efficient representation of conditional dependencies. This makes them more suitable for certain types of inference problem where directionality is important. Markov network overview. Markov networks are also known as Markov random fields are another type of graphical model. They represent dependencies using directed graph focusing on the joint distribution of a set of variables. While they are powerful, they do not facilitate the same type of conditional independency reasoning as Bayesian network. Probabilistic model for images, Markov random fields, application in image segmentation and texture modeling. Probabilistic graphical model. Probabilistic graphical model encompasses both Bayesian network and Markov network. They provide a unified framework to represent the reason about uncertainty. This broad category allows for the integration of various probabilistic method and inference technique. Structure learning techniques. Structure learning can follow a constraint based, score based, and or hybrid approach. Constraint based approaches use statistical tests to identify independence relationships among variables. Score based methods evaluate different structures based on how well they fit the data using metrics like BIC or AIC. Conclusion. Bayesian networks are powerful tools for modeling uncertain and probabilistic reason. Their versatility allows them to be applied in various fields, from healthcare to finance. Continued search and advancement will further enhance their capabilities and reach. Thank you.